In our previous video, we looked at a Vedic math technique called the Niklam Sutra. Using this technique, we were able to rapidly solve multiplication problems involving numbers close to 10, our base. With a bit of practice, I said that these problems could be solved mentally. I hope you attempted solving a few while on the bus or perhaps while on the treadmill. In this video, we will build on the technique and use it to solve bigger problems such as these. Now imagine you were to use the conventional method to solve a problem like this. And the next problem given to you was this. The second problem would take much longer to solve than the first, and even then, chances are high that you would not be sure of the answer. This is not the case with the Niklam Sutra. The second problem would take longer, yes, but marginally so. Okay, I have made quite a few pompous statements out here, so now it's time to prove my point. Here is our first problem. 98 times 92. As you can see, both these numbers are close to a nice and easy base, which is 100. Having numbers with lots of zeros in them makes multiplication problems easy, as we all know. Give a student a problem such as 13 times 12 and he may blink a few times. But give her a problem such as 13 times 100 and that may evoke a smile, even though the multiplier is a much bigger number. So this then is one of the key objectives of our method. Identify easy to manipulate base numbers. Alright, let's get back to our problem. Both the multiplicand and multiplier are different from the base. So our next step is to find these differences. 98 is 2 less than 100. 92 is 8 less. We write this down. We then add the first number and second difference number. So 98 plus minus 8 is 90. Alternatively, we can add 92 and minus 2, which gives us the same answer. Having this option is great since you can choose the easier one if pressed for time. Our next step is to multiply this result with our base. 90 times 100 is 9000. This was easy to do thanks to our simple base number. We then multiply the two difference numbers. Minus 2 times minus 8 is 16. And finally we add both results. 9000 plus 16 is 9016, our final answer. But is this correct? Let's use a calculator to find out. Great, let's move on. You may have noticed that in the previous example, both the numbers were less than the base. In this next example, we will multiply numbers larger than the base. So what is 112 times 107? First question, what is our base? 100? Yes, I agree. Now let's calculate the difference numbers. 112 is 12 more than 100. 107 is 7 more. Let's write this down. We then add the first number and second difference number. Alternatively, we add the second number and first difference number. Let's try the second option for a change. 107 plus 12 is 119. And multiplying this result with our base, we get 11,900. We then multiply both difference numbers. 12 times 7 is 84. If you were not sure of this answer, you could have used the base 10 method to get it. Alright, now we add both results. 11,900 plus 84 is 11,984, which is our final answer. Let's once again validate our answer. Cool, it is correct. The multiplication is such a common operation that one would assume that methods exist to quickly check if an answer is correct, in the absence of a calculator. The good news is that such methods do exist, and we will look at one called the cast out nines method in our next video. With the confidence gained from using such methods, we will slowly start reducing our reliance on calculators. Let's now move on to our next example. So far we have seen numbers close to 100. But what happens when one or both numbers is much bigger or smaller than our base? Here's a problem highlighting this fact. What is 45 times 93? Let's first identify our base number. 10 does not make sense as a base since both numbers are much larger. 100 makes more sense even though 45 is much smaller than 100. Let's stick with 100 and see how far we get using it as a base. Now let's calculate the difference numbers. 45 is 55 less than 100. 93 is 7 less. Let's write this down. Now we add the numbers and difference numbers. 45 minus 7 looks much easier to calculate than 93 minus 55. And by now we know that both answers should be the same. So 45 minus 7 is 38. And multiplying this result with our base we get 38 times 100, which is 3800. Now we need to multiply the difference numbers. In the past few examples this was the easy bit since we had small difference numbers. 55 times 7 is not too bad, so let's continue. 55 times 7 is 385. And adding 3800 and 385 we get 4185. Let's check our results. Yep, it is the correct answer. I think it really makes sense to see what happens when both numbers are far from the base. So here is our next example. What is 55 times 65? Ideally, we would have used another base such as 60 for this problem. But other bases is the topic of the next video. So let's stick with 100 and see what happens. 55 is 45 less than 100. 65 is 35 less. We then add the first number and second difference number. 55 plus minus 35 is 20. That wasn't bad at all. We then multiply this with our base. 20 times 100 is 2000. Now here comes the tough part. We need to multiply the difference numbers. Minus 45 times minus 35 is almost as hard as 55 times 65. A bot mission. As this example demonstrates, avoid choosing large difference numbers when using this method. Alright, we have looked at quite a few examples of base 10 and 100. Hopefully you are now confident to put this technique into use for bigger problems. So let's look at 2. What is 996 times 1007? Which base would you choose for this problem? I would go with 1000. We next find out the difference numbers. 996 is 4 less than our base. 1007 is 7 more. We write this down. We then cross add. I will choose the second option. 1007 minus 4 is 1003. And multiplying this result with our base, we get 1,003,000. We then multiply the difference numbers. Minus 4 times 7 is minus 28. And don't forget the sign, guys. And adding both results we get 1,003,000 minus 28, which is 1,002,972. I'm not going to use a calculator to validate my answer this time. I just feel that it's right. So here is one last monster of a problem to end this session. What is 99,983 times 99,994? Pause for a moment and contemplate how long this would take to solve using the conventional method. Not a pretty picture, right? Okay, let's tackle this monster. What is our base? Yes, it is 100,000. So 99,983 is 17 less than our base. 99,994 is 6 less. We write this down. I will then add the first number and second difference number since that looks easier. So 99,983 minus 6 is 99,977. And multiplying this with our base we get 9,997,700,000. Multiplying our difference numbers we get minus 17 times minus 6, which is 102. And adding both results we get our final answer, which is 9,997,700,102. I'm not sure if a standard calculator will be able to arrive at an answer, but like the previous case, I feel confident and I hope so do you. So this brings us to the end of the session. In our next video, we will look at multiplying numbers close to other bases and also look at this great method for validating multiplication results. Thank you.